Okay, in this lesson, you're going to learn to calculate both the present value of a single deposit investment as well as that of a periodic deposit investment. So let's go ahead and get started with some definitions first. Okay, so the overarching question here is how can you determine what you need to invest now to reach a financial goal in the future? Okay, so the current value of a deposit that is made in the present time is called the present value. You can determine the present value of a single deposit investment, such as a CD, which means that you can calculate how much a one-time deposit should earn at a specific interest rate in order to achieve a certain dollar amount in the future. Okay, and you can also determine how much to save on a regular basis. So this is going to be multiple deposits or multiple regular deposits at a specific interest rate to meet that future goal. And that is called the present value of a periodic deposit investment. Okay, so we're looking at present value of a single deposit investment and then present value of a periodic deposit investment. Now, if you were to use the formula for the future value of a single deposit investment that we learned in a previous lesson, you can determine the present value by the following. Okay, so we have this equation, P is equal to B, so P representing the principal or the initial amount, that's going to equal the balance, so the total balance at the end of the period divided by 1 plus R over N raised to the NT power, where R is the rate, my apologies, where R is the rate in decimal form divided by N, which is the compounding frequency, raised to the compounding frequency times the number of years. Okay, now if you don't recall what the original formula was for finding the future value of a single deposit, that formula was B, right? The total balance at the end of the term is equal to P times 1 plus R over N to the NT power, okay? So this equation here comes from this equation, and it is essentially solving for P algebraically, so we're dividing both sides by this entire quantity. And when you do, P is then equal to B divided by that entire quantity, okay? Now, we could also use the formula for a future value of a periodic deposit investment by the following formula, okay? Now, again, this is just a algebraic maneuver of solving for P when we knew what the equation was for B. And if you recall, the equation for B was B equal to P times the quantity 1 plus R over N. Again, R is in decimal form, raised to the NT power. N is the compounding frequency, T is the number of years, minus 1, okay, so this whole thing divided by the rate over N, okay? So again, taking this equation, which is the future value of a periodic deposit, periodic being more than one deposit at a specific frequency, we said that the ending balance was going to be P times this entire quantity divided by R over N. So if we were to solve for P, then it's going to be B times this fraction divided by this entire thing. Okay, so we're just in an algebraic maneuver. All right, so let's go ahead and see how this is applied in an example. Okay, so in this example, we have Mr. and Mrs. Johnson. They know that in 6 years, their daughter Anne will attend a state college, and she's going to need about $20,000 for the first year's tuition. The question is, how much should the Johnsons deposit into an account that yields 1.5% interest compounded annually in order to have that amount? Okay, so the first thing we want to ask is, when they make a deposit, are they making a single deposit or are they making multiple deposit? Okay, so the question tells us, how much should the Johnsons deposit into an account that yields this amount of interest? So this is a one-time deposit. Okay, so we are going to use the following equation. P is equal to B divided by 1 plus R over N raised to the NT power. Okay, so that is the equation we are going to use to solve for the question, how much that deposit needs to be. Okay, so we know that they're going to need $20,000 at the end of 6 years, okay? And that's going to be divided by 1 plus the rate in decimal form, so this is going to be 0.015, divided by the compounding frequency. Here it's compounded annually, so the frequency is just 1, raised to the 1, which is the compounding frequency again, times t, which is 6 years, okay? And if we go ahead and punch that into the calculator, we would get $18,290.84. Okay, so that is how much the Johnsons need to deposit today, so that in 6 years, they'll have $20,000 for their daughter Anne to cover her first year's tuition. And this is for an account that yields a 1.5% interest compounded annually. Okay? All right. So that is our answer. And let's go ahead and move on to example number 2. So Ritika just graduated from college and she wants $100,000 in her savings account after 10 years. Okay? So the question is, how much must she deposit in that account now that earns a 0.95% interest rate, and this is compounded daily in order to meet that goal? Okay, so again, in reading this example, we need to determine, is she making a single deposit or is she making a periodic deposit? Okay, and so the question here is, how much must she deposit in that account now? So that means it's a single deposit, which means we're going to use the equation that we used in the previous example again, and that is P, which is how much does she need to deposit now. It's going to equal B, which we know to be 100,000 because that's her goal, and that's going to be divided by 1 plus the interest rate in decimal form. Even though this is the interest rate is 0.95%, we have to put it in decimal form, so that's going to be 0.0095, okay, divided by the compounding rate, or the compounding frequency. This is telling us it's compounded daily, so there are 365 days in a year, so the compounding frequency is going to be 365. And that's going to be raised to the NT power, which is 365 times 10 years. Okay, and plugging that into the calculator, we would get the following: $90,937.41. Okay, so this is how much Ritika needs to deposit into her account now if she wants it to grow to $100,000, where the account is compounded daily at 0.95% interest rate. Okay, so let's go ahead and take a look at the last example, example 3. So we are told that Nick wants to install central air conditioning in his home in 3 years. He estimates the total cost to be $15,000. Okay, so the question is, how much must he deposit monthly? Okay, so now instead of a one-time deposit, this is going to be a periodic or multiple deposits, and here we're told monthly, into an account that pays 1.4% interest compounded monthly. Okay, so how much does he need to deposit? So the equation we're going to use is as follows. Let's go ahead and take a look at this equation here. So let's go ahead and put that over here so we have a reference point. All right, so this is the equation we are going to use. And so we're going to go ahead and plug in the values, okay? So B is going to be the final amount that Nick wants, and that's $15,000. And that's going to be multiplied by the rate in decimal form, 0.014, divided by the compounding frequency, which is monthly, so that's 12 months in a year, okay? And that's all going to be divided by 1 plus the rate in decimal form again, divided by the compounding frequency, raised to the power of the compounding frequency, 12, times 3, which is 3 years, okay, all subtracting 1. Okay, and if we plug that into the calculator, we would get the following: $40.82. Okay, so this is how much Nick needs to deposit every month for the next 3 years into an account that pays 1.4% interest compounded monthly. Okay? All right, so hopefully that made sense, and I hope that the equations that we're using didn't throw you off. If any of this was confusing or if you need further clarification, please go back to the beginning of the recording and listen to it again. Thank you.